Welcome to Maths with EJD. I started talking about applications of integration in the last video, and this is a continuation of that. So there we talked about how integration can be applied to find the area between a curve and some, maybe x-axis or y-axis or whatever, or the area between two curves and so on. So here we are turning our attention to the application of integration in the area of kinematics. So don't forget, when we started talking about integration, right, we saw integration as anti-differentiation. So it means what you did with differentiation, you can reverse it with integration. So just like you could find, remember kinematics also, I said we saw that kinematics is paying attention to motion without the force causing it. So we are paying attention to displacement, velocity, and acceleration. So, and we also know that given displacement, right, to get velocity, differentiate displacement to get velocity, differentiate velocity, you get acceleration. In the same way, you can integrate acceleration to get velocity and integrate velocity to get displacement back. And that is what this is about. So going back to kinematics, right? Now from the lens of integration, so you need to understand that given the velocity function v of t, we can obtain the displacement s of t. So it's like you're reversing what you did in differentiation. So from an initial time t1 and a final time t2. So in that case now, the displacement s of t is actually s of t2 minus s of t1. And in form of integral, that will simply be integral of v of t dt from t1 to t2, basically. And the same can apply to velocity. You can get, if you have acceleration, you can get velocity, right? So for an acceleration function a of t, we obtain the velocity vt on the interval t1 less than t2. So t between t1 and t2, you can obtain your velocity. So v of t now is v of t2 minus v of t1 minus integral of a of t dt from t1 to t2. So it's like that. So we take our first example. What is the distance traveled by a vehicle with velocity v of t, which is 3t minus 4 kilometers per hour for the first 7 hours? So that's time from 0 to 7, right? That's what that means. So we calculate the displacement as follows. Displacement s of t is equal to integral of 3t minus 4 being velocity dt from 0 to 7. Of course, we know already that displacement s of t is integral from initial time to final time of velocity of t dt. And that's exactly what translates here. So you have 3t minus 4 dt. And then, of course, you can integrate straight up. 3t, if you integrate 3t, you have 3t squared over 2. So that's 3 over 2t squared. If you integrate 4, you get 4t, and that's to be evaluated from 0 to 7. So like I like to do, I split things up. So you have 3 over 2t squared from 0 to 7 minus 4t from 0 to 7. And then we have, so 3 over 2 into 4t squared, put 7, you have 7 squared minus, put 0, 0 squared, minus 4 into, put 7, that's into 40, you have 7 minus 0. And then that's, 7 squared is 49, minus 0, that's 49. 49 times 3 is 147 divided by 2, minus 28. 4 times, minus 4 times 7 is minus 28. This is 0, so nothing to worry about. So you have 147 divided by 2 minus 28 over 1. That's like 147. LCM is 2, right? 2 into 1 times 147. That's 147 minus 28. And that is simply 91, right? 147, 28. Oh, sorry. Not 28. So 1 in 2 is 2. 2 times 28 is 56. Sorry, 56. So you have 147 minus 56, and that is 91 all over 2. And then that ends up being 45.5 kilometers. So it means that within the first 7 hours for a vehicle traveling at this speed, it would have covered 45.5 kilometers. All right. So that is how to get displacement if you're given velocity. Okay, so let's see the next example. So find the velocity v of t meter per second of an object between the third and fifth seconds if the acceleration is given by a of t equals t squared minus t plus 1 meter per squared second. All right. So we calculate the velocity as follows. So we already know we are looking for velocity. So we know velocity is integral from t1 to t final, or t2 if you like, equal of a of t dt, like that. So that's integral. So specifically third to fifth second. So between the third and fifth second, you want to know what the velocity is. All right. So you have v of t equals integral from 5 to 3 t squared minus t plus 1 dt. Okay. And then you just integrate t squared, you get t cube over 3, which is 1 over 3 t cube, minus integrate t, you get that's t squared over 2, that's minus 1 over 2 t squared. Integrate 1, you get t from 3 to 5. So you have 1 over 3 t cube from 3 to 5, minus 1 over 2 t squared from 3 to 5, and t from 3 to 5, or 5 to 3 if you like. So now you start evaluating. So for t cube, put 5, you have 5 cube minus 3 cube, then minus 1 over 2. 5 here, you have 5 squared minus 3 squared, then t, 5 minus 3. Then you just tidy things up. So you have 1 over 3. You have 1 over 3 into 5 raised to 3 is 125. 125 minus 27 is 98. Okay? Minus 1 over 2. 5 squared is 25 minus 9, that's 16. 5 minus 3 is 2. So again, you have 98 over 3. 16 over 2 is minus 8 plus 2. Add all of that up, you get 80 over 3 meter per second. I mean, for assurance, you have 98 over 3 minus 8 over 1, 8 over 1 plus 2 over 1, right? So LCM again is 3. So you have 3 in 3, 1 times 90, that's 98, minus 1 in 3, 3 times 8, 24, plus 1 in 3, 3, 3 times 2 is 6. So that's 98 minus 24 is 74. 74 plus 6 is 80. So that's why you have 80 over 3 meter per second as your velocity that you're looking for. So within the third and fifth seconds, the velocity of the object is 80 over 3 meter per second. Okay, so that's the end of this, but then we have some exercise as usual. We have some exercise for this, and that's basically these last two questions on this slide. The last two questions here. So that is talking about the question, this question and this. These are the ones, these are the questions related to kinematics. So, like I said, I'll still project all the exercise at the on the last video, after the last video, right? I mean on at the end of the last video. So if you have not subscribed, make sure to do that, and hit the notification bell so you can get alerted when a new video comes. Thanks for listening. See you in the next video.